Hello everyone, I Nikhil welcome you to Vigyan Bharat. In this video today I'm going to discuss the problems of the day for today, that is 1st of August. The subject which I have taken today is integral calculus, and the topic from this subject is the problems from where problems will be on this topic, double and iterated integrals over rectangles. So today I have a total of around, I would say, 5 problems, 5 good interesting problems for you. So try to go through each of them. There will be some very cool concepts in between. You will be going to learn a lot. So try to attempt these. Let me just quickly write the first problem of the day and explain it to you. In problem 1, you have to evaluate the following iterated integrals. Evaluate the following iterated. Now this word is important for us. Iterated integrals. Under this, I have taken 2 parts. Try to solve them. In the part 1, you have this integration for range of y from 0 to 1, then range of x from 0 to 1 again, and the integrand is y upon 1 plus xy dx dy. So this is the first part. The second part is as follows. Try to evaluate this iterated integral by iterated. We mean that, as you can see here, the limits of the integration in part 1 are constants. In general, they can be functions also there, not necessarily be constant, but here we have constants. So you can, while solving the integrals, you can change the order in which you want to integrate. So this is the advantage of having the limits when the limits are constant. So this is the advantage we have over iterated integrals. Later in coming days, I'm going to give you some good interesting problems which are often asked in examination based on reversing the order of integration. That is also a good concept. This is the first problem, so try to solve both of them. Now let's move to the second problem of the day. Let me change the ink. Yeah. In the second problem, what is given to us? You have to find the volume of the region bounded above by the paraboloid this is the paraboloid, the equation of the paraboloid, z equals x square plus y square, and bounded below by the square, Now the square is a region in R2, which I denote by this R, and the limits, the region lies between basically this one. Your x varies from -1 to 1, your y also varies from -1 to 1. So you try to find the volume of the region bounded by the paraboloid, whose equation is z equals x square plus y square, and bounded below by the square. So you trying to find the region bounded by both of these, the square and the paraboloid. Okay. So now let's discuss the third problem. In the third problem, you have to use a theorem which is known as Fubini's theorem. Fubini's theorem. So try to first read the statement of this theorem. This is very important. So using this Fubini's theorem, you have to evaluate this integral. Values of y varies from 0 to 1. Values of x varies from 0 to 3. X e to the power xy dx dy. Try to understand here one thing, how I am able to know what are the values of x and what are the values of y, how I am able to distinguish. If you see the order of integration, first I am integrating this integrand first with respect to the variable x and then with respect to the variable y. So these limits which I have over here, these limits are for my x first, and these limits are for my variable y. They are given in the order in which this double integral is given. Okay. So try to solve this problem. First try to read the statement of this Fubini's theorem and then use that statement to evaluate this integral. Try to answer me in the comment box if you have any doubts over it. Let's move ahead to the fourth problem of the day. Fourth problem. In fourth problem, you have to find, this is a good problem again, find the value of the constant k. Find the value of the constant k so that the following holds. Integration over 1 to 2 for y, 0 to 3, this is the range, this is the values of x. Now this is my integrand kx square y dx dy, and this equals 1. So try to solve this and find the value of k. Now I gave you the last problem of the day. This is a very good problem, so try to solve it carefully. You have to evaluate this double integral for x lying between -1 to 1, y lying between 0 to 2, 0 to pi by 2, sorry, x sine of square root of y dy dx. So try to solve all the 5 problems one by one. Very interesting problems these are, because in every problem we're going to learn something. So I have choose very good problems whose level of difficulty varies from easy, middle to, I will not say they are hard, but they are good. So try to solve each and every problem. If anywhere you have any doubts in these problems, you may send the solutions in the Telegram group. There we can have a discussion on it if you are finding anything difficult, or if you have any queries based on them, then you can drop a comment in the comment section. And if you find this video to be useful, then do share this video and the content which we are making among your friends. So try to solve this problem. Thanks so much for watching.